Hello friends, welcome back to the channel. This is Aaheli presently studying statistics and data science as you already know. And today we are diving into one of the most important chapters in statistics, which is measures of central tendency. Don't worry, I'll make sure it's super clear and fun to learn, okay? So, what are we going to study? The properties of real good statistical average, okay? And then for today's topic, we will be covering arithmetic mean, the properties and the disadvantages. And for the next videos, we will continue with the median and mode, okay? So, yes, let's start. First topic, which is first, actually, let's start with the introduction. What are measures of central tendency? They are the statistical measures that tell us about the central value of a dataset. Central value of a dataset. So, around which the observations tend to cluster, okay? Around which the observations tend to cluster. So, like in simple words, it's like asking, what is the typical value of my data? Hmm? In simple words, how do you ask it? What is the typical value of my data? And the answer is the central tendency. Okay. And guess what? There are three main measures of central tendency. First is mean, next is median, and third is mode. Mean has got three types again. First is arithmetic mean, then geometric mean, then harmonic mean. All these are independent in different ways and have their own applications. For example, the arithmetic mean is the most commonly used, but in some cases, GM, like the geometric mean, and HM, harmonic mean, may be more appropriate. Okay? First, let's start with the properties of a good statistical average. Okay, wait. Properties of good statistical average. Before we start the formulas, let's quickly check the five properties of a good average. Okay? First is it should be rigidly defined, like no confusion about what it means. Rigidly defined. Next is it should be simple to understand and easy to calculate. Simple to understand and easy to calculate. Third is it should be based on all the observations. Based on all observations. Fourth is it should not be unduly affected by extreme values. Not be unduly affected by extreme values. Fifth is it should be capable of further mathematical treatment. Capable of further wait, further mathematical treatment. Okay, so let me highlight the important terms. First is rigidly defined, then it should be simple to understand and easy to calculate, based on all observations, not be unduly affected by the extreme values, capable of further mathematical treatment. Okay, now we'll come to arithmetic mean. The arithmetic mean is the most commonly used measure. It is simple. It is simple and it is the sum of all observations divided by the number of observations. Okay, that's all you need to know for arithmetic mean. We will discuss the formulas too. Just a moment. Just a moment. Yes. So the AM of a set of observations is the sum of the observations divided by the number of observations. Okay, that is x bar. We denote arithmetic mean by x bar. Okay, so x bar is equal to summation of xi by n, where I runs from 1 to n. This basically means x1 plus x2 plus goes on till xn divided by n. Okay, in case of frequency distribution, in case of frequency distribution, where fi is the frequency of xi, the formula will be x bar is equal to summation of fi xi by summation of fi, where I runs to 1 from n, same for here. Okay, also the mean for the grouped frequency distribution, mean for grouped frequency distribution can be obtained by a particular method. That method is step deviation method. Step deviation method. What is the formula for it? Let me write it, then I'll explain the terms. X bar is equal to A plus summation fi xi by summation fi. I runs from 1 to n into C. Okay, here A is assumed mean. Okay, and C is a class width. Okay, I'm sorry. I wrote here xi. Actually, it should be ui. Okay, so here ui, wait, ui means xi minus a by c. All right. Now coming to the properties of AM, properties of arithmetic mean. First is algebraic sum of the deviations of a set of values from their AM is equal to 0. Wait. Yes, algebraic sum of the deviations of a set of values from their AM is equal to 0, which is xi minus x bar is the deviation of first observation. Now, if you want the proof of it, we write it like this. Summation of xi minus x bar, I running from 1 to n, basically means summation of xi, I from 1 to n, minus nx bar, which now means nx bar minus nx bar, which equals to 0. And this proof is similar for frequency distribution too. Similar for frequency distribution. If I have to write it, it will be like this. Summation fi xi minus x bar is equal to summation fi xi minus x bar summation fi, which here means nx bar minus nx bar, which equals to 0. Here n is equal to summation fi. Okay, so yes, that was the first property. Now coming to the second property, which is sum of squares of deviation of a set of values is minimum when taken about mean. Okay, this basically means summation xi minus a whole square, where I running from 1 to n, it is minimum when a is equal to x bar. Alright, now coming to the third property. Third property is if two variables x and z are related such that z is equal to ax plus b. There, a and b, I mean here a and b are constants, then z bar is equal to ax bar plus b. Okay, now we can understand it like with two examples or questions. Okay, let's understand it through questions. How will your mean be affected if all the observations are increased by 2? Can you solve it? Let's start solving it. Observations, which is the x bar, or the original mean, let's say. Wait a minute. Yes. Let's say the original mean will be what? X bar is equal to x1 plus x2, and will go until xn divided by n. But here the new observations are increased by 2. So it will be x1 plus 2, x2 plus 2, x3 plus 2, and so on till xn plus 2. All right. Then the new, sorry, new x bar will be what? x1 plus 2, x2 plus 2, and so on till xn plus 2 divided by n. Right? If we calculate it, x1 plus x2 goes on till xn plus 2n. 2 n times, right? So 2n by n. Now, if we again further calculate it, x1 plus x2 goes on till xn by n plus 2n by n. You can understand where it is going, like x bar plus 2. Hence, we proved it. All right. Now we will come to the next question to understand the next part. Next question is, how will the mean be affected if every observation is multiplied by 3? See, the original observation or original mean is equal to x1 plus x2 plus goes on till xn by n. New observations now are multiplied by 3. So observations will be 3x1, 3x2, 3x3, and so on till 3xn. All right. Then new x bar will be 3x1 plus 3x2 and so on till 3xn by n, which further calculated will be 3. We took the common part out, then x1 plus x2 and so on till xn by n, which basically means 3 into x bar. Hence, mean will also get multiplied by 3. We proved it. Hence proved. Now we will come to composite mean. Composite mean means, wait, let me write it. Composite mean. Sometimes data is divided into groups and we want the overall mean. That's where composite mean or combined mean comes in. What is the formula for it? Formula is x bar is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. This is actually very important. Okay. So like if you understand it, if a group of n1 observations has am which is x1 and another group of n2 observation has am of x2, then the mean of the composite group, like the groups taken together, is given by this formula. This is composite mean. This x bar is also called the grand mean when we take all the observations together. Like let's say x1 bar is equal to summation x1I and n1. I here running from n1, 1 to n1. Okay. This means actually this whole data set, this means x11, x12, x13, and so on. Here, basically x1I means the summation is n1 x1 bar. Okay. So yes, now we have, what do we have left? The disadvantages of mean. The last topic. Disadvantages of mean. So the first disadvantage is AM can't be used if we are dealing with qualitative characteristic. Okay, can't be used if we are dealing with qualitative characteristics. Next is AM can't be obtained if an observation is missing or lost unless we drop out the observation. Okay, can't be obtained if an observation is missing. Okay. Number three, it is important. AM is affected by extreme values, that is outliers. Affected by extreme values, which also means outliers. So, like in case of outliers, AM gives a distorted picture of the distribution, basically. And point number four is this is also important. Point number three is very important, and point number four is also very important, which is AM can't be calculated for open end classes. Can't be calculated for open end classes. For example, below 10 or above 20. So yes, this is all about mean. If you want to solve few questions, I can give you few questions. For example, see, let's do few questions, okay? The first question. There are two branches of a company employing 100 and 80 persons respectively. If the AMs of the monthly salary paid by two branches are rupees 27500 and rupees 22500, find the AM of the salaries of the employees of the company as a whole. Okay, find AM of the salaries of the employees of the company as a whole. How do you solve it? Yes. So the mean is, see, 100 N1, and the X1 is, or the AM, 27500 plus 80 N2, 22500, right? Divided by 180, 100 plus 80. Just now we considered it. So the answer is 27500. Four zeros actually. And then 18, 1, 2, 3, 4, 5. Five zeros divided by 180. Answer will be 25277.7. You are free to use the calculator, but please try and learn to use the scientific calculator, okay? So this is the answer. Let's solve another question. The mean monthly salary paid to all the employees in a certain company was rupees 500. The mean monthly salary paid to male and female employees were rupees 520 for male, and female will be rupees 420 respectively. Now, what is the question? The question is to obtain the ratio of male to female employees in the company. Okay, now you need to solve it. How will you solve it? First, see 500, the mean is given. N1, you don't know, but you know the value for AM for the male, and N2 is 420 divided by N1 plus N2. All right. So now cross multiplying 500 N1 plus 500 N2 is equal to 520 N1 plus 420 N2, which means 80 N2 by 20 N1, and hence it means N, no, yes, let's say N1 by N2 is 4 by 1, which is basically 4 is to 1. This is the answer. Okay. Now, if you want to solve another question, let's say this is the last question for today's topic. Okay. Another question is the mean age of a group of 100 children was 9.35 years. The mean age of 25 of them was 8.75 years, and that if another 65 was 10.51 years, you need to find what was the mean age of the remaining children. What was the mean age of the remaining children? Okay, how will you calculate it? Again, by combined mean. See, the total mean is given as 9.35. See, for 100 it is 9.35. Therefore, for first 25 it is 8.75, then the next 65 it is 10.51, and for the rest of the 10, you don't know the mean, right? All divided by 100. Then by calculating, 935 is equal to 218.75 plus 683.15 plus 10 with the third mean divided. No, not divided. We have already calculated. So yes, wait. Further calculating, it will be 935 minus 901.9 is equal to 10 third mean. Therefore, x3 bar is equal to 33.1 by 10, which is 3.31. This will be your answer. Okay. And that's the complete session on measures of central tendency with a focus on arithmetic mean for now. In the next video, we'll move deeper into the next topics, which is the geometric mean, harmonic mean, and then the median and mode with examples. So yes, if you have liked the session, don't forget to like, share, and subscribe for more fun stats lessons. And yes, so bye. This is Aaheli Bhattacharya signing off. Bye. Take care.